Mass refers to the amount of matter contained in an object, which is a measure of its heaviness. It is a scalar quantity, meaning it has magnitude but no direction. It is typically measured in kilograms or grams. Unlike weight, which depends on gravitational force and can vary depending on location, mass remains constant regardless of the object's environment. Mass plays a critical role in various physical equations and concepts, such as Newton's laws and motion and the law of conservation of mass. Acceleration is the rate at which an object changes its velocity over time, which includes both speed and direction. It describes how quickly an object speeds up, slows down, or changes direction in relation to a reference point. Measured in units, such as meters per second squared, acceleration can result from various forces acting upon an object. For example, when a car accelerates on a highway, it increases its speed if it comes to a stop. It decelerates, showing negative acceleration. Understanding acceleration is essential for analyzing motion and predicting future positions of object under the influence of forces. So when I start running, I start slow and I'm slowly accelerating, which means I go faster over time.
Position refers to the specific location or arrangement of someone or something in a space. Describes where an object is situated relative to a reference point, which can be defined in terms of coordinates, distance, or direction. Understanding position is crucial in various fields, including physics, navigation, and geographic, as it helps us determine how objects relate to one another and move through their surroundings. For example, in a coordinate system, an object's position can be represented by numerical values that indicate its distance from established axis. This is my position, then I'll walk to Bryce's position. That's it, stop recording.
Force is defined as a push or pull acting upon an object, which can cause it to accelerate, change direction, or deform. It's a vector quantity, meaning it has both magnitude and direction. Forces can arise from various sources such as gravitational attraction, friction, tension, or applied pressure. Understanding force is essential in physics, as it helps us explain the movement and interaction of objects within different environments. So if I push against Harry, I have more force against him because that's why he moves. But if I push against this wall, it won't move because I have equal force.
That's not a wall.
Gravity is a natural force that attracts a body towards the center of the earth or any other object with mass. This fundamental force governs the motion of celestial bodies and keeps planets in orbit around stars. The strength of gravitational attraction depends on the masses of the objects involved and in the distance between them. As described by Newton's law of universal gravitation, gravity not only causes objects to fall towards the ground, but also plays a crucial role in various phenomena such as tides, the formation of galaxies, and the stability of ecosystems on Earth. Dropping something on the table. Like
It went down.
as a gravitational pull.
Yeah.
Go. Motion is the process of changing position over time relative to a reference point. It can involve various types of movements, such as linear, rotational, or oscillatory, and is characterized by factors like direction, speed, and acceleration. Motion is a fundamental concept in physics, allowing us to understand how objects interact and move in a relation to one another. Whether it's the movement of a car on a road, a planet orbiting a star, or a pendulum swinging back and forth. Studying motion helps us grasp the principles that govern the physical world. My hand is moving, so that means it's in motion because it's moving from point A to point B. The net force is the vector sum of all of the forces acting on an object. When multiple forces are acting on an object, the net force is the combination of these forces. Taking into account their magnitudes and directions It can be calculated by adding or subtracting the individual forces, considering their vector of nature. So consider, this is the mass and this is a box. I'll be pushing up against it 40 newtons, and here we're pushing 30 newtons. So it's slowly gonna go more because I'm pushing 10 newtons more against it.